right, guys, we are looking at factoring the greatest common factor. Shh. Hi, I'm teaching up here, so you're not talking. I'm going to look through the greatest common factors. So, we're looking at, we've been doing like one number, finding the greatest common factor with a factor tree. What we're looking through here is the biggest number that goes into 6, 12, and 24. What is the biggest number that goes into all of them? 6. Because 6 can go into 6 one time, right? So I know that was my first instinct too, was like, well, 3 goes into all of them. But we can think even bigger than that. Okay. Now we have two unlike terms. We couldn't add these together, right? We've got 12x and 6. But there is a greatest common factor of the two of them. What goes into 12x and 6? 6. Right? And 12x would become 2x and 6 would become 1. Does that make sense? Okay. I am going to write down now what they would become because we're going to have to do that further along. Okay. What goes in to 15x and 9x evenly? 3x, right? Okay. And if we took 15x and we divided it by 3x, we would get what? And if we did it by 9, we would get? Yes, Martha, speaking. Yes. He just came in. Yep. Yep. Yes. Yep. Okay. So, we are going to then, what goes into 3x? You guys said 3x, right? Okay, good. So, we are going to then go to number 5. What goes into a squared, a to the 4th, and a to the 6th? A squared, good. So a squared goes into a squared one time. A squared goes into a to the 4th, a squared times. A squared goes into a to the 6th, a to the 4th times. And that's just a little rule about exponents. Okay, they would have to add up to each other. A squared plus a squared gives you a to the 4th. Okay? Or times. A squared times a squared gives you a to the 4th. A squared and a to the 4th gives you a to the 6th. Okay? All right, let's look at number 6. You guys ready? Okay. We have x to the 5th, y to the 3rd, x to the 8th, y squared. What goes into both of those? How many x's can we do? So we've got 5 x's here and 8 x's here, right? It's like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, right? How many of those can I take to the outside? 5. Because there's 5 of them here, right? So there's only 1 left over. There's x to the 3rd is left here. Miss Murphy speaking. All right. Yep. Bye. Mady, I guess you're being signed out. Josh, you're being signed out. Cameron, can you take a seat, please? Okay. Okay. All right. Yeah. Okay, so if we look, I can take out all 5 of these x's, and I can take out all 5 of these x's, and there's nothing, and then there's only so many left over. Okay? You're pulling them out. Yep, that's what's left. This is y to the 3rd, and this is y squared. So there's 3 of these y's, and there's 2 of these y's. Shh, I'm in the middle of teaching and recording. Thanks. Okay. So I can take away y squared. Okay, what I want you guys to think about with this is what I would have left over. I would have y, and I would have x to the 3rd, right? X to the 5th, y squared times y gives me x to the 5th, y to the 3rd. X to the 5th, y squared times x to the 3rd gives me x to the 8th, y squared. So I'm taking, this is what's left over. I can take that out of all of them. We'll keep doing more. We'll keep doing more. Okay. Let's look at 7. Okay, I want you to just look at the x's right now. What's the smallest one? x squared, right? So I know I can take at least x squared out of each one of those. And I have at least one left over. I can do 1. What's the smallest y? Y to the 6th, y, or y to the 5th? Y. Okay, let's look at factoring a polynomial now instead of monomials. Monomials are just single ones. There's nothing being added or subtracted. These are polynomials. See how they have a subtraction sign in between them? Or an addition sign. Okay. What can I take out of 7x and 14? 7. So if I take out a 7, I'm left with x. 7 times what gives me negative 14? Negative 2, right? Somebody is calling me and I do not recognize that number. Okay. Number 9. What goes both into 16x and negative 8? What can I take out of both of them? 8. So 8 times what gives me 16x? What's 8 times what gives me 16? 2. And it has an x, so I have to make sure I have an x there. Right? What times 8 gives me negative 8? 8 times 2 is 16. What times 8 gives me negative 8? Negative 1. See, it's kind of like the opposite of the distributive property. You can check it by doing the distributive property, and we should get the same answer. Okay, 10. We've got 3 different things here. What does 5x to the 3rd, 10x squared, and negative 15x? What's the greatest common factor of all of them? 5 goes into 5, 10, and 15 evenly, right? How many? What's the smallest x? X, right? Okay. 5x times what gives me 5x to the 3rd? I have 1 x here. I have 3 x's here. How do I get that 3x? I have x squared plus 5 times what gives me 10? 2. And I have x squared, so I need x times what to give me x squared? X. Good. Okay. 5 times what gives me negative 15? Negative 3. Do you see that if I distribute this, I get the same thing? So this right here, I'm going to do it in a different color. I get 5x to the 3rd. 5 times 2x is 10x. 5 times negative 3 is negative 15x. That's like my little check. All right, let's turn it over. Okay, so this is what I want you to do in class. This is your classwork. I want you to look at the back. I want to check it in before the end of the hour. Okay, so you have 15 problems. Work together, ask me questions, and I want you guys to get this done before the end of the hour, and I'll check your answers, and then you should be able to do your homework, which is almost exactly the same as what we've just been doing. Okay? So this is what you're going to get done in class. I've got the answer key right here already done. So once you're done, you're going to come and we're going to check it. Okay? Any questions? All right, let's turn the light back on.